Today we will study successive derivative. Writing a function in alternative form using series, using an infinite series. Consider a GP, geometric progression. First term is a, second term ar square, ar cube, nth term is ar raised to n minus 1. First term is a and constant ratio is r. What about the sum of n terms? Sn equal to a plus ar square plus ar cube plus and so on ar raised to n minus 1. Multiplying both the sides by r, we get rsn equal to ar plus ar square plus ar cube plus ar raised to 4 plus and so on ar raised to n. Subtracting this from first one, minus, this term cut out, this cut out, this cut out, this cut out, this and this cut out. So Sn minus Rsn, that is 1 minus R into Sn, equal to a minus ar raised to n. So Sn is a into 1 minus r raised to n upon 1 minus r, if r not equal to 1. Now consider a GP, 1 plus x square plus x cube plus x raised to 4 up to infinite terms. Here Sn is a into 1 minus r raised to n upon 1 minus r, but the first term is 1, a is 1, constant ratio is x by 1, x square by x, etc. x raised to n upon 1 minus x, r is x. If mod x is less than 1, that is minus 1 less than x less than 1 and moreover x not equal to 0, then as n tends to infinity, this term mod r raised to n goes to 0, 0.1 into 0.1, 0.01, 0.1 into 0.1 into 0.1, 0.001, etc. This way, this term goes to 0. So as n tends to infinity, this expression goes to a into 1 minus 0 upon 1 minus r, a upon 1 minus r, here 1 upon 1 minus x. Let's suppose that it is possible to write such a function as a series expansion so that we have f of t equal to a naught plus a1t plus a2t square plus a3t cube plus a4t raised to 4 plus and so on. Here f of 0, these terms are 0, so f of 0 is a naught. If we differentiate with respect to t both the sides, f dash t, a naught is constant term, so 0, a1, a2 into 2t, a3 into 3t square, a4 into 4t cube plus a5 into 5t raised to 4. If we take t 0 here, f dash 0 is a1, these are 0. F double dash t, so a1 is 0, a2 into 2a2 into t1, a3 into t square derivative 2t, a4 into 4 3t square, a5 into 5 4t cube, etc. If we take here t equal to 0, f double dash 0 is 2a2, that is 2 into 1 into a2. Now f triple dash t, so here it is 0, 3a t into 2, t derivative of t is 1, a4 into 4 into 3t square 3 into 2t, a5 into 5 into 4t cube, so a5 into 5 into 4 3 t cube derivative of 3 is 3t square and so on. If we take 0 here, t is 0, f triple dash 0 is 3 into 2 into 1 into a3 and all the rest terms are 0. Similarly, we get f 4 dash 0, 4 times derivative, we get 4 into 3 into 2 into 1 into 4, a4. Thus, we can see that a naught is f of 0, a1 is f dash 0 upon 1 factorial, a2 is f double dash 0 upon 2 factorial, a3 is f triple dash 0 upon 3 factorial. Similarly, a4 is f 4 dash 0 upon 4 factorial. Now, thus f of t equal to f of 0 plus f dash 0 upon 1 factorial into t, f double dash 0 upon 2 factorial t square, f triple dash 0 upon 3 factorial t cube, f 4 dash 0 upon 4 factorial t raised to 4, etc. Applying this rule for f of t equal to e raised to t, here f dash t is e raised to t, f double dash t is e raised to t, f triple dash t is e raised to t. We know that actually that dt of it e raised to t is e raised to t as the same. According to this rule, f of t is f of 0 plus f dash 0 1 factorial into t, f double dash 0 1 factorial into t square, this. But f of 0, that is e raised to 0, it is 1, f dash 0 is also 1. 1 upon 1 factorial into t. F double dash 0 is also 1. T square upon 2 factorial, t cube upon 3 factorial, t raised to 4 upon 4 factorial, adds on infinite terms. For any t belongs to R, the series is convergent because it's a finite number, and these are infinite terms, and they are equal. So addition of infinite term is a finite number, so series must be convergent. That is the sum of infinite term goes to e raised to t. For example, taking t equal to 1, e raised to 1 is 1 upon 1 plus 1 upon 1 factorial plus 1 upon 2 factorial, 1 upon 3 factorial plus 1 upon 4 plus 1 upon 5 factorial, etc. These are infinite terms. But the answer, the sum, goes to particular number, and it is 2.7182. It is Euler number, sum of infinite series. Did you know where did e come from? An important limit. The limit x tends to 0, 1 plus x raised to 1 upon x. It is e. If you think x tends to 0, 1 plus x tends to 1. And 1 upon x, because x tends to 0, so 1 upon x tends to infinity. So, the limit should be 1, but it's not right. 1 plus x tends to 1 as x tends to 0, and 1 upon x tends to infinity. So, according to our common sense, the limit should be 1, but the common sense is not common. It is not true. Let's check. Y equal to 1 plus x raised to 1 upon x. If x equal to 1, y equal to 1 plus 1 raised to 1 upon 1, it is 2. If we take x equal to 0.1, this one is 1.1, this one becomes 10. So 1.1 raised to 10, it is 2.593746. If we take x equal to 0.01, 1.01 raised to 100, it is 2.70481389294. And if we take x equal to 0.001, y equal to 1.001 raised to 1000, 2.7169239. And as x tends to 0, 1 plus x raised to 1 upon x goes to this number. It is not recurring, not ending, it's an irrational number, Euler number. And for digital electronics, it is very important. Do you know ddt of e raised to t is e raised to t itself? For any function y equal to f of x, dy by dx, it is rate of change of y with respect to x. It is limit h tends to 0 f of x plus h minus f of x upon h. This is change in x. Sorry, this is change in y, delta y, and this is change in x, so delta x. But delta y by delta x is average rate of change of y with respect to x. But if we apply limit